Welcome to Curie Electronics. Today we are going to solve HSFC, that is Human Flight Center Technician B Electronics question paper, and the exam was conducted on 13 March 2022, that is yesterday. Okay, let's start now. First question. Inductance is inversely proportional to number of turns, area of cross section. So what is the equation for a air core inductor, or what is the equation for inductance? That is L equals mu a n square upon L. Here n is the number of turns, mu is the permeability, and what is A? Only A will write it here. A equal to area encircled by coil. And if we see here, L is in the denominator. So that means inductance is, that is L, inductance is inversely proportional to length. Length is the right answer. In a series resonant circuit, impedance is, how the series resonant curve looks. On the x-axis what we have the current. On the y-axis we have the current, x-axis we have the frequency. And if you draw and if you plot the graph, we will get a shape like this, and that whatever the peak value is coming, this is the resonance frequency, and we will have at 3 dB points we have F1 and F2. F2 is the 3 dB points. We can say 3 dB or 70% of the maximum current. This maximum current, let it be I0. That is 0.07 I0. That is the F1 and F2 points. Now here in this, one more thing I'll tell you. Here in the right side of this resonance frequency, XL is more, and the left side of the resonance frequency, XC is more. Now what is the question? In a series resonance circuit, impedance is, see, at resonance what is happening, maximum current is, we are getting maximum current. That means at resonance, impedance equal to resistance at resonance. At resonance. So at resonance, our impedance is purely resistive. So the answer is option C. Purely resistive is the right answer. So for the ideal op-amp shown, what is the V out waveform? So we have a op-amp given in figure. That is the non-inverting terminal. Then we have the inverting terminal. What has shown? Inverting terminal, non-inverting terminal, that is we have mentioned as V into equal to 0, and V out, and what is the waveform he has given? He has given a sine wave. If this is the V in, what is the V out? First of all, This is the open loop configuration. So it is not going to act like a amplifier at all. Okay. So whatever the three waveforms he has given, A, B, C, it doesn't match. It's all wrong. This is actually a zero. We can say it's a comparator, or we can say it's a zero crossing detector also, because input is at zero. Zero crossing detector. Here what happens? Now ideal, we are considering an ideal op amp. Now V in equal to 0. During the first positive half cycle, what is happening? Our non-inverting terminal, inverting terminal, okay, that is the negative sign. Inverting terminal is higher than the non-inverting terminal. Then we will get a waveform like this. It goes down like this. And during the negative half cycle, what is there? Our non-inverting terminal is higher than the inverting terminal. So we'll get a waveform like this. So the answer is none of the above. We'll get a square waveform from here. And that will be inverted, because see, now for an op amp, whenever inverting terminal voltage is less than the non-inverting terminal, that means non-inverting voltage is high, then you will get a plus output. When non-inverting terminal is less than the inverting terminal, then you will get a negative voltage. Yeah, we don't want, not making it complicated. None of the above is the answer. A voltage gain for which of the following configuration is the highest? I think all of us know it is the common emitter. Question number 5. How many states are there in a 4-bit ripple counter? So 4-bit ripple counter means it starts from counting from 0, 0, 0, 0, 0, 1, 2 up to what? Up to 1, 1, 1. 1, 1, 1, 1. So it is counting from where to where? It is counting from 0 to 15. So actually, how many states are there? Total 16 states are there. 16 states it is changing over. That answer is 16. 3 cascaded decader counters will divide the input frequency by. The answer is option D is the right answer, because a decade counter has got 10 states. Like that, we are cascading 3 decade counters, so we'll get the counter will divide the input frequency by 1000. 2 BCD numbers. The addition of 2 BCD numbers 1001 and 0100 represented in BCD form. That means in the sum we have to show in BCD form. What are the numbers? That is 1001. In BCD, what is this? This is 9. And what is the other number? 0100. This is 4. If we add these two numbers, what do we get? We get 14. No, not 14, 13. And now, how do you represent 1? This 1, how do we write it? This 1 we can write it as, in BCD form I am writing 0, 0, 1, and 3 we will write it as 0, 0, 1, 1. So which is the right answer? Option C is the right answer. Question number 8. If the output of an XNOR gate is 1, then the input combination is. So what do? Just draw the XNOR gate. This is the XNOR gate. A and B are the inputs. Y is the output. Now all of you know what is the XNOR gate truth table or truth table. Okay. 0 0 0 1 1 0 1 1. In XNOR gate, whenever the inputs are same, we will get output as 1. So we will get 1 0 0 1. Now read once more the question. If the output of an XNOR gate is 1, then the input combination is, the output will be 1. Then there are two chances. Input can be 0 0 or 1 1. So in the option D is the right answer. That is, it can be B or B and C. Option D is the right answer. Delay time is measured between dash percentage voltage levels of input and output waveforms. Now we have a just we'll take it as a buffer. Okay, here our input and this is our output. Now input waveform is like this. So there will be some delay before it reaches the output. Okay, now from where we measure, this is the output, and this is the input waveform. Now from where to where we will measure the delay? We measure the delay from the 50% of the input. If it is 5 volt, it should reach 2.5 volt. Okay, from here also it should reach around 2.5 volt. At 2.5 volt here. Now what is the delay from here to here? This is what we are measured. That means 50% of the voltage level we will measure the delay. So the answer is option A is the right answer. Option A is the right answer. Question number 10. What happens the current in the series circuit if the net resistance is doubled? So this is based on the Ohm's law. What Ohm's law says, V equal to IR. Now what we have to find out? We have to find the current. Circuit current I equal to V upon R. This is the first condition he is telling. What happens to the current in the circuit, in the series circuit, if the net resistance is doubled? Now I equal to V upon, we are doubling the resistance to R, which this we can write it as 1 upon 2 multiplied by V upon R. V upon R we know. What is that? I. So 1 by 2 I. So what happens? What happens to the current in the series circuit if the net resistance is doubled? It becomes half of its original value. It becomes half of its original value. That is the right answer. Question number 11. Sorry. The reason for using amplitude modulation for broadcasting is, see, amplitude modulation, actually we won't get, it is not more immune to noise. It will pick up noise, and it is not more, it's not high fidelity also is not there. FM is more more clear, and that will say fidelity. It has better selectivity and sensitivity. That also wrong. It will, whenever we tune AM channels, it will pick up some other nearby channels also. We use, the reason for using amplitude modulation broadcasting is it avoids receiver complexity. The receiver making is very simple. That is, it avoids receiver complexity. The starting torque in single phase induction motor is the starting force in single phase induction motor. In a single phase induction motor, there is no rotating magnetic field, no RMF, that is rotating magnetic field. Rotating magnetic field. Or we can say one is the forward magnetic field and one is the backward magnetic field, and the torque will be 0. So the starting torque in a single phase induction motor is 0. So what do you do how this motor starts in the induction motor? There will be one more auxiliary winding. Then only we can start this induction motor. We also use capacitors also. So let's go to the next question. Question number 13. Sorry. What is the degree of the polynomial 3xy minus 3xy minus 5x square y plus 2x square y square plus 4? If you see, this is a polynomial, but it has got two variables, that is x and y. Two variables are there, that is x and y. Now what you have to do? You have to take the components of them and add it. We have to components be exponents. See, x square is there, so 2 plus y. What is the y exponent? 3, so it is 5. And for this term, if you take the degree, so here for the 2x square y cube, the degree is 5. Similarly, if you take here, then it is exponent of x is 2. 2 plus y is 1, so it is 3. So here if we take, it is 1, 1, so it is 2. So the degree of the polynomial is sum of exponents of the variables. So highest, what is the degree? Here the highest value we have to take. So it is 5. 5 is the degree of this polynomial. Option D is the right answer. Question number 14. He has given a sine A minus cos A equal to 0. Sine to the power 4A plus cos to the power 4A we have to find. Next, so I'll write it as sine A equal to cos A. Sine A, at what degree sine A value equal to cos A value? That is sine 45 degree. At 45 degree, so we will get A equal to 45 degree. So now you got the value of the angle sine A equal to 45 degree. Now what he is telling in the question, the remaining part, we have to find sine to the power 4A. What is the value of sine to the power 4A plus cos to the power 4A? Now, what is the value of A? 45 degree. That is sine to the power 4, 45 degree plus cos to the power 4, 45 degree. What is sine 45? 1 upon root 2. Cos 45 also same, to the power 4 plus this also 1 upon root 2 to the power 4. If you do simplify, what do you get? 1 upon 4. See, first one, what do we do? First we can take the square of it. The square equal to what? 1 upon 2. Again 1 upon 2 square if we take, we'll get 1 upon 4. So plus 1 upon 4. So 4 quarter. Correct. 1 by 4, 1 by 4. If we add, we should get 1 by 2. So you'll get 2 here. If we simplify this, 1 by 2. So 1 by 2 is the right answer, or half is the right answer. Question number 15. It's a direct question. The total internal RAM memory of the 8051 microcontroller is 128 bytes. Switch mode power supply SMPS are based on the dash principle. What is the principle? We use a PWM to turn on and off a switch. The switch across input of the switch is going to be a higher voltage. Then by doing that on and off, we can get a lower voltage. That is also called chopper. Chopping the input voltage using a MOSFET or a power transistor. So switch mode power supply SMPs are based on the dash principle, chopper. We can say it's chopper. Question number 17. What is the component shown in the picture? This all of you know, it's a polarized capacitor. Normally we will write the symbol for electrolytic capacitor, but it is polarized. If it is a voltage source, then they will definitely show the polarity, plus and minus they will show. And if it's a non-polarized capacitor, they will just draw a symbol like this. Question number 18. A bridge circuit is used for measurement of the following. Bridge circuit. Let's say Wheatstone bridge. This is for what we use to measure resistance. Then what about Maxwell bridge? Maxwell bridge we used to measure inductance. Then what about sharing bridge? We used to measure dielectric loss. So now come back to the question. A bridge circuit is used for the measurement of the following, that is resistance, capacitance and inductance. Option D is the right answer. Question number 19. Arrange in increasing order of resistivity. So that means the resistivity should increase the material. Resistivity is just opposite to conductivity. Now, so if we see here, the first what should come, aluminum should come first, that we know. And glass is going to be higher resistive material. Then the glass should be the fourth one. Okay. Deionized water is there first. So this option A you can neglect. This also we can neglect because increasing order of resistivity he told. So aluminum should come first. That has got the lower resistivity. Then we are left with two more. See this deionized water. See deionized water is used as insulator in some applications. That means it should have high resistivity. So the right option is here is option B, that is aluminum will be a good conductor. After that seawater will conduct, then deionized water, and finally glass. Option B is the right answer. Question number 20. Which of the following makes silicon N-type semiconductor? That means we have silicon. We want a N-type semiconductor. That means we have to add a pentavalent impurity. Pentavalent impurity we have to add. This will give a N-type semiconductor. Pentavalent impurity means fifth group element. That is fifth group antimony arsenic. Antimony arsenic also we can say. So antimony or arsenic. So its answer is option D. But all other these three elements, that is gallium, aluminium, gallium, indium, all are trivalent impurities. These are trivalent. This also trivalent. Trivalent. So if we add this, we will get a p-type semiconductor. So to get n-type semiconductor, we have to add a fifth group element, that is antimony arsenic. Question number 21. What is the type of MOSFET the figure represents? First of all, whether it is P channel or N channel. And the arrow is going out. Arrow is going out. And we know N channel and P channel is just opposite of transistor case. In transistor, if arrow is going out, it is NPN transistor. But if arrow is going out in a MOSFET, it is a P channel MOSFET. P channel, just opposite. P channel. So now we know the answer is going to be option A or D. But whether it is depletion mode or enhancement mode, when you draw the symbol, if there is a break between the lines, there is a break between the these lines, then it is enhancement. Enhancement. Option A is the right answer. So what if it is a depletion? This is the enhancement. If there is no break, just a line like this is there, and you have, this is the depletion. If it is like this, it is depletion. Depletion. So the right answer is option A. It's an enhancement MOSFET. Question number 22. Question number 22. Now here, period of a function is measured as. Period of a function, what he meaning? When you measure the waveforms or using an oscilloscope, how do you take the period? Let us take one example. We have a sine function. Okay. Now, if I take from here at this point, that is, it is crossing the zero from a lower value to higher value. So if I want to know the period, it is crossing the zero from a lower value to higher value. So up to here I will get the period. So it is correct. We can measure the period. Zero crossing point, we can measure the period. But let me take for the next, let me take from here to here what I will take. From here for the next what I will do, positive peak of one cycle to negative peak of next cycle. If I take this is a positive peak and this is a negative peak, then I am not getting the period. I am not getting the period. So if I repeat this process again, what happens? I will miss some part, then again I have to go for positive peak and negative peak. So the right answer for, we usually see whenever we want to measure the period, we will take either zero crossing, that is going up or down, or peak to a positive peak or negative peak. So for this question, right answer is, but not positive peak and negative peak. So the right answer is option A is the right answer. Question number 23. A 1-to-1 transformer are used for, that is isolation transformer. That is option A is the right answer, because see why do we use see what we do, we use sometimes some 1:1 transformers, that is to isolate the electrical connection from the input side. So option A is the right answer, to isolate part of circuit electrically. Part of circuit electrically means what? See, after the transformer we won't get the direct shock from the mains line. Okay. Question number 24. A monostable 555 timer based multivibrator has R equal to 120 kilo ohm and the time period is 1000 millisecond. Calculate the value of C. So we have to find the value of C. How do you find? Now, what is the equation? All of you know, that is 1.1 RC. So here what is given? He has given 1000 millisecond, that is 10 to the power minus 3 equals 1.1. What is the value of R? 120 kilo ohm. 120 10 to the power 3 kilo ohm. C we have to find. So what is C? What is C? So C equals 1000 multiplied by 10 to the power minus 3 divided by 1.1 multiplied by 120 to 10 to the power 3. So now again I will write it as 1000 multiplied by, from the denominator, that is this 3, I am taking it up, 10 to the power 3, I will take it up. So it has become 10 to the power minus 6 upon 1.1 multiplied by 120. What is 11 multiplied by 12? What do you get? 11 multiplied by 12, you will get 132. So it is 132, right? If you simplify this, what do you get? 1000 divided by 132, which is going to be a suitable option here. If you look at the options, option A, option B, option C, option D, it is going to be 7. It is going to be 7.5 microfarad. So 7.5 microfarad. If you have doubt what you can do, you put the value here. Put the value here. This 120 kilo ohm and 7.5 microfarad, you should get 1 second. 1000 millisecond means 1 second. So the right answer is option C is the right answer. That is 7.5 microfarad. Question number 25. The peak value of voltage of 220 volt AC main is. What is 220 volt? Whenever we say AC, means it is the RMS value he is giving always. So what is peak value? Peak of this 220 volt, that is we have to multiply this by root 2, 220. What you will get? You will get 1.414 multiplied by 220. This is, we need not to do solvation because we know it comes around 311 volt. So which is the answer? Option C is the right answer. Question number 26. Slip of an induction motor increases with. See this slip in the induction motor. What do you mean by slip? The slip is given as a slip equal to ns upon ns minus n. Ns is the synchronous speed. N is the rotor speed upon ns. This is the slip. And this slip increases with increasing load. When the load increases, the slip increases. When the load increases, what you have to do? Torque has to increase. To increase the torque, current has to increase. So what it should. So the slip of an induction motor increases with torque and current, with increase in current and torque. Option B is the right answer because torque will increase, so naturally current has to increase. So increase in current and torque. Question number 27. A wire of length L and of Question number 27. A wire of length L and of circular cross section of radius R has a resistance of R ohms. So R he has given as, first condition he is giving rho L upon A, that is rho L he has given capital L here, wire of length L, rho L. What is A is telling? Radius he has given, radius R. That is, what is the area if you know the radius? That is pi r square. I am usually familiar with pi d square by 4. If I simplify this, rho L, what is this d square? That is 2 times resistance square, 2r square upon 4. We can directly write it because I am familiar with the pi d square formula. I am using it. So 4r square upon 4. So what will we get? We will get directly this pi r square. We can write it as rho L upon pi r square. See so much we need not to write. Directly we can write this equation. That is, this is equal to r, he is told. This is the first equation. Now what is happening? Another wire of same material and cross-sectional radius 2r will have the same resistance r if length is. Okay, length we have to find. Now what is the thing? R is going to be same. R he wanted same. Then what is going to change? So a rho, this L dash is a new L. And here what is going to be? 2r. Radius is changing. It is going to be 2r. So pi 2r pi r square 2r square. Again, if you simplify, rho L dash pi 4r square. Now if we see, if we compare these two equations, what is there? A rho L dash 4 pi r square. 4 pi r square. To keep this resistance R, we have to cancel out this 4. Correct. This 4 we have to cancel out. Then only we can keep the resistance R constant. Resistance R. So then what you have to do? We have to increase the length of the length by 4 times. When L dash equal to 4L, we get R, so that we can keep the resistance same. What is the question? A wire of length L and of circular cross section of radius R has a resistance of R ohms. Another wire of same material and cross sectional radius 2R will have the same resistance R if the length is 4 times the length of the original wire. 4L. 4L is the answer. 4 times. So let's move to the next question. Question number 28. So here what we have to find out. In the following circuit, D1 and D2 are ideal diodes. The current I1 and I2 we have to find. See, in these diode problems, what we do? We have to assume, we can assume diode is on or off. Then we have to simplify this. So first what I will do, assume D1, D2 open. That means they are not conducting. So I will replace the circuit as per that. So what do I get? So what do I get? Let me draw it. So I have a 5 volt supply plus minus 5 volt. Then I have assumed both the diodes are open. Okay. So here I have 500 ohm, 5 volt. So this is 5 volt, 500 ohm. And the next diode also I have assumed it is open. By assuming open or closed, I am trying to find out whether the diodes are forward biased or reverse biased. Here it is plus minus 3 volt. Now if we see, now we will get the idea of the voltages. See here, if I keep a voltmeter here, a voltmeter this point here, what it will read? This is going to be 5 volt here, and this point also going to be 5 volt. That means the D1 diode is connected with the same potential. So for a diode to on, what has to be there? If it is VA and this is VK, VA should be greater than, the anode voltage should be greater than the cathode voltage, then only it will get on. If you apply same voltage, it is off. That means, what it means, our D1 diode is actually off and there is no current flow. That means we can say I1 equal to 0. We can write I1 equal to 0 because D1 diode is connected across the same potential. So I1 is 0. So it is going to be option A or C. Now we have to find which is A or C. And now what about the D2 diode? This is our D2. See, D2 diode. D2 diode, if we see here, it is 5 volt and the other terminal is 3 volt. So definitely it is forward biased. So it will act like a short circuited diode, short circuit, because it's an ideal diode. So only that part I will redraw it. Let me draw it a little more left side. So this is the I2. We want I2 only. Here we have the diode. Diode will replace it by a forward bias, short circuit, because we understood the diode is forward biased. And this is at 3 volt. And here it is 5 volt. Now this circuit is 500 ohm. Now all of you are good in calculating this. What is the thing? We can apply KVL. That means what is that? I2 equals 5 minus 3 upon 500 ohm. What will come? It is 2 upon 500. What is 2 divided by? So this we can write it as 2 upon 5 multiplied by 1 upon 10 to the power square, right? Which equals 2 upon 5 will get 0.4 into 10 to the power minus 2. That means it is 4 milliamps is the right answer. 4 milliamps is the right answer. So it is going to be option A, I1 and I2. I1 equal to 0 amps, I2 equal to 4 milliamps. Option A is the right answer. Question number 29. This if you have used Excel, you know, actually I have searched for it. It is sum equal to the formula for sum from cell C2 to C12. This is the right formula. The colon, not comma. And the last question, divide the binary numbers. Last question for the first part. Okay. So we have a binary numbers 1 1 1 1 0 1. This we have to divide by what? 1 0 0 1. I will convert both to decimal. So it is 2 to the power 5. 1 2 3 4 5 6. So 2 to the power 5, that is 32 plus 16 plus 8 plus 4 plus 1. So what it comes? 48, 56, 60, 61. And what is this? This is equal to 9. By looking at itself, we can say it's 9. So it is actually 61 upon 9. Divide the binary numbers and find the remainder. He is asking what is the remainder? Okay, remainder is what is asking, remainder. So 9 6 are 54. That is 9 multiplied 60 equal to 54. 7 is the remainder. 7 how do you write? In 4-bit 0 1 1 1. So option D is the right answer. So we have completed the first 60 questions. The remaining questions we will do it in the part 2. This paper was not so difficult, but they have included some diploma topic little bit. The diode problem was little more difficult, and otherwise I feel it is okay. But there is a good question paper. So if you like the video, please share with your friends and don't forget to hit the like button. And thanks for watching.